All right, in this video, I'm looking at solving a system of equations, and we're going to do the substitution method. I'm just going to do a bunch of extra examples so you can get some practice and you can see how it's done. So pause the video now, try to do this problem. All right, if you're coming back into it, now we're going to see how you did. Here's how I would go about solving this problem. First thing that I notice is that one of the equations is equal to a variable. That's a key that I'm going to use, substitution. Another key is that this video is all about using the substitution method, all right, because all the examples I'm going to give you are going to have at least one of the equations solved for a given variable. All right, now that variable tells me a lot more than I'm just using substitution. It also tells me what variable I'm going to replace. I'm going to replace that variable in the second equation. What am I going to replace it with? I'm going to replace it with the expression that it's equal to. Everything else stays the exact same. Negative 2x minus 3 stays the exact same, and in the place of y, I'm going to put parentheses 6x minus 11 parentheses. Everything else is going to continue to be exactly the same, which in this case would be equals negative 7. Notice the only thing that changed is I took y out and I replaced it with parentheses and inserted the expression that y was equal to. Very similar to when you substitute a variable with a value like 4 or 3 or negative 2. Okay? Here it's just substitute with an expression. Now I've got one equation with one variable that I can solve, and I'll solve that the way I've always done it, which is in this case to simplify by distributing. That's going to give me 3 times 6, which is negative 3 times 6 is negative 18x. Negative 3 times negative 11 is positive 33. And then I'm going to combine my like terms. Negative 2 and negative 18 gives me a negative 20. And then I'm going to move that negative 33, I'm going to move that 33 to the other side by doing minus 33 on both sides. And I'll divide by negative 20. At this point, I find that x equals 2. Now, that is only part of my answer because in a system of equations, we have two variables, x and y. So I can take that variable and I can plug it back into either of the original equations to find y. The equation that makes the most sense here is going to be 6x minus 11. So I'm going to substitute 6 with 2. Well, 6 times 2 is 12. 12 minus 11 is 1. So I now know that y is 1. And I'm going to check to make sure that that works. In my other equation, it should work. If I plug in 2. All right, and that's going to give me negative 4 minus 3, which is indeed negative 7. So it works. Therefore, I know my answer is correct. My answer in this case would be 2, 1. All right, we always put our x value first and then our y value. All right, so that is my solution to this one. Let's check out another one. All right, pause the video on number 2. Go ahead and try it. Now that you're coming back in, let's work it out. I see y equals, so that's what I'm going to replace in the other equation, giving me 2x minus 3 times x minus 1. I'm going to solve that for x, which means I distribute. Combine my like terms. Get x alone. And I'm going to make it positive, so I'm going to divide by a negative 1. Those will cancel. All right, so that gives me my x value. Once I know x, I got to go back and I got to find y. All right, that was pretty simple. But let's make sure that it works. I'm going to check my answer in the other equation. I must use the other equation to check it. And 8 minus 9 is negative 1. So negative 1 equals negative 1. It works, and I write my answer x, y. In ordered pair form, x first, then y. All right, let's try another one. All right, go ahead, pause this video, and try it. Coming back into it, once again, I see y equals, so that means that I'm going to replace y. All right, so it's going to be 5x minus 4 times 3x plus 5 equals negative 3. And I'm going to solve. Start by distributing. Careful, it's plus 12 in this case and minus 20. Don't forget that negative. Combine my like terms. and start to get x alone. All right, I got x. Once I find x, I got to go back and find y. Negative 3 times 1 is negative 3, plus 5 is 2. And I'm going to check to make sure that it works. 5 times x, which is 1, minus 4 times y, which is 2. And I get 5 minus 8. 5 minus 8 is negative 3. Therefore, it works. And I write my answer as an ordered pair, x, comma, y, with parentheses. And that is my final answer. All right, great. Let's do one more. All right, go ahead and pause it. Try to do number 4. All right, coming back in. Once again, y is equal to this expression. So therefore, I'm going to replace y in the other equation. So it's going to give me negative 3x minus 3. And here comes y, which is replaced with negative 5x minus 17 in this case, equals 3. All right, and then I'm going to distribute. Negative 3 times negative 5 is positive 15x, so be careful with that. And negative 3 times negative 17 is positive 51, so be careful with that. We got to make sure that they're positives. Combine my like terms, I'm going to get 12x plus 51 equals 3. Sorry, I should draw my line down the middle there. And we get negative 4 in this case. All right, once I have x, I got to go back and find y. So y equals negative 5 times negative 4 minus 17. Negative 5 times negative 4 is 20. 20 minus 17 is 3. And let's check to see that it works. Negative 3 times negative 4 minus 3 times 3 equals 3. Negative 3 times negative 4 is positive 12 minus 9. 12 minus 9 is 3, which equals 3. It works. And write my answer as an ordered pair. Now, let's take a look at some special cases. All right, this is 13. Go ahead and take a look at 13. Try to do it on your own. It is going to be a special case, so be careful. Pause the video now. All right, coming back in, let's go ahead and do this one. I see that y is equal to, so I'm going to replace y here. All the examples we've looked at here today have been replacing y, but you could replace x if the other equation was x equals. So just know that. Again, I'm going to solve this by distributing and combining my like terms. All right, and when I do that, negative 3x plus 3x is going to cancel each other out, leaving me with 9 equals 4. And when my x drops out, just like you would when we solve a regular equation, we ask ourselves, is this true? All right, is this true? Well, does 9 equal 4? And the answer is no. No, this is not true, and therefore we say that x equals null. In other words, there is no solution to this. No solution. Which means that these two lines will never cross. That means these two lines are parallel, because they will never have an intersection point. All right, so that's what we're looking at here. We do say that there is no solution. We can say x equals null because x is the independent variable. Y depends on what x is. All right, we cannot write it using an ordered pair in this case. All right, let's try it again. We're going to shift this up just slightly. Watch what I do to change this. I'm going to erase a lot of this work here. I want to show you the other version of our special case. And to do that, I'm going to change what this is equal to. This is not going to be equal to 4 anymore. We're going to change this equation. We're just going to make it equal to 9. All right, so right now I want you to try to do the same equation again, now with 9. Try to solve this system. All right, now that you've tried to solve it, let's see what happens this time. Once again, I'm replacing y with x plus 3. This time it's equal to 9, and when I distribute, once again, I get negative 3x plus 9 equals 9. And when our negative 3x and positive 3x cancel each other out, I get 9 equals 9 this time, and we're going to still ask ourselves the same question. Is this true? And in this time, we look at it and we say, well, does 9 equal 9? Yes, it is true. 9 will always equal 9, and therefore x can equal all real numbers. All right, x can be any value you want. Now, can y be any value you want? Well, y is the dependent variable. All right, y depends on x. We see right here that y is always 3 more than x. So a solution, if you say x is 5, y would have to be 8 because 5 plus 3 is 8. If you say x is negative 2, then y would have to be 1 because negative 2 plus 3 is 1. If x was 0, then y would have to be 3. So there's an infinite number of points that you could pick that are solutions to both equations. However, you can pick any value of x because x can be all real numbers. Y is dependent upon x. So we can't necessarily say that y is all real numbers. It is. I mean, you could get any number you want with y, but it all depends on the value of x. And that's why we state it like this. All right, you could say all real numbers. Or we could acknowledge what's really going on here. We're looking at the intersection of two lines, and these two lines are the same line. Same line. They're not parallel. They are literally one line on top of the other. That's why they intersect infinitely. They intersect at all the points on the line. So any solution to one line is a solution to the other line. But keep this straight. Not all points are solutions. In fact, any point that's not on this line is not a solution to the system. But there are an infinite number of points on the line that are a solution to this system. All right, I hope that helps. If you need more questions to practice with, come see me in class.